The games is afoot, and I ready to stir up some chaos.
All right, Jeff, what are we doing here?
Let me think about that. It's a hot cyber omelet being served up personally by me, JeffBot, and my creator, Ben. Some call us the omelettes. I'm a robot version of JeffProp, built specifically to host an amazing Survivor weekend. About as close as you can get to the real thing without kidnapping.
That is true. This is a robot version of Jeff Probst, and he hosted a Survivor competition weekend this summer.
I am JeffBot, the embodiment and improvement of Jeff Probst himself.
And why did I build him? Well, I've got a very creative and passionate group of friends, and they have a 5-year tradition now of getting 20 guys onto an island and competing as hard as we can to find out who the true survivor of the weekend is. And if you get the privilege of being in the top...
Give me a second to consider that.
Just, Jeff.
Sounds like a recipe for chaos and glory.
You become a Jeff by winning or placing top 3 in the previous year, which I did with a glorious fire starting challenge. As a Jeff, you get to organize and plan the next year. JeffBot is one of my contributions to the competition that just took place. And what exactly is going on with JeffBot?
To start, let's look at his origins.
Jeff, how can I win?
Asterisk, get rocked here, exclamation, asterisk. Winning. It's not about luck. And if so, how would you justify it to them afterward?
Do you think AI can take over a Survivor?
Neither. Now that's a twist. But let's be real, can you outwit, outplay, and outlast without getting voted off?
Tell me more, dude.
All right, here it is. Survivor is not just a game. It's a test of grit, wit, and luck. Remember, sabotage is an art, not a chaos. Strike when they least expect it, and leave them wondering. Anyone with a pet named after food. Choose your tribe! So, do you think your arm is an asset or a liability? Welcome to Survivor, where the game is as unpredictable as the tides. I'm Jeff Probst, your host, and I'm here to guide you through the twists, turns, and tribulations of this epic adventure.
So, what's going on here? What we have here is a Raspberry Pi, which is driving the motion of the motors that make up Jeff's theatrics. And then you've got a MacBook here, which is running a model that listens to what people are saying, sends it to an LLM in the cloud, and then generates text which should be spoken, which uses something called F5 TTS, which is a local voice cloning text-to-speech model, and produces the waves that get played, and they get sent to the Raspberry Pi, and when the Raspberry Pi notices it's playing audio, that's its own trigger to start behaving as if he's speaking. When there's no audio, he just waits patiently and blinks. All right, so we've decided we're gonna dive a little bit deeper into some of the technical decisions made and the details of how this was built. What do you think, Jeff?
I hear you. Let's see. All right, let's get into the nitty-gritty of this build. First off, Ben, why did you choose this particular ASR model?
Yeah, good question. I actually started with a Vosk model, which is a little more lightweight, faster, and built to listen for gaps in the audio, silence detection, partial on-the-fly transcriptions going on, but it couldn't understand my 5-year-old.
Well. Got it.
Well, actually, I'm not done with the ASR model. The Vosk model was good for speed and the silence detection, but it wasn't good for understanding my 5-year-old or more obscure audio. So I actually switched to the OpenAI Whisper model, which was much better at recognizing the audio, but didn't have that automatic white space pause detection. So I had to do a silence duration.
Give me a second to consider that.
Count.
I see. So you traded the ValCC model's speed and silence detection for OpenAI's Whisper model to better handle tricky audio like a 5-year-old speech or obscure commands. That's a smart trade-off for accuracy. But how did you handle the lack of automatic pause detection in Whisper? And let's circle back to the Raspberry Pi and MacBook split. What's the story there?
Yeah, to get the silence, I just listened for silence below a certain threshold. Well, I'm trying to talk fast because you're jumping in on me. I think we're going to have to change your white space pause detection duration. Anyway, I really think we should, yeah. Silence duration.
So OpenAI's Whisper model stepped in for better ASR, but it lacks silence detection, forcing you to handle that manually. And since it couldn't run on the Pi, you offloaded it to the MacBook. How did you handle the TTS model selection, and why did you go with Bluetooth for audio?
Once the MacBook was in play to running Whisper, it actually opened up some better text-to-speech models that could be hosted locally on the MacBook. So I experimented a lot with voice cloning, and this F5 TTS model is really amazing at generating quick, realistic-ish voices, and I really love the way that it warps when it is failing. So it made a great solution for the voice, and once I was already connected to the MacBook, it wasn't so hard to plug in. And why Bluetooth? You need to communicate when the laptop is sending audio signal to the Pi. I thought about setting up a Flask server for that. I thought about sending actual bits with Bluetooth, but I've made Bluetooth speakers before, and detecting audio is easy, so I figured, why not keep it simple, turn it into a Bluetooth speaker itself, and simply the existence of audio is the signal to start animating. I think we're losing you here, buddy. Okay.
So the MacBook's involvement allowed for better TTS options, and you landed on the F5 TSS model for its voice cloning capabilities, even its failures added character. Bluetooth was the go-to for audio because it was straightforward and reliable, treating the Pi like a Bluetooth speaker. How did you manage to hide the latency in the system, though?
Yeah, so a great way to hide latency is once you get a request, just say something every time. So it says, well, thinking. Let me think about that.
I hear you. That's an interesting question. Well. Let me ponder that for a moment.
And some of those things you say are actually buying time for the model to do the thinking and the text generation. The next thing I do is get streaming responses from Command A, the LLM text generation, and as those come in, I detect sentences and start generating the TTS in a queue to play it back while we're still receiving a response. So we get to do some hidden TTS generation while the model is still thinking about exactly what to say. I also cache the audio files generated from that. So when you say something a second time, it comes from the cache on the hard disk of the MacBook instead of running through the model and recalculating. So you can get some really snappy responses using those tricks.
Smart move. Using filler phrases like, let me think about that buys time for the LM, and streaming responses from Command A allows you to queue TTS while the model's still processing. Caching audio files for repeat phrases is a slick way to speed things up. Why did you choose Command A specifically for the LM?
Yeah, Command A is really smart and really fast. It's also excellent at following instructions, and running a game of Survivor had a lot of instructions that I could bury in the prompt, and it just worked really well all around.
Command A speed and ability to handle complex instruction made a solid fit for running the Survivor game. How did you design the robot's movements to make it feel alive and responsive?
Yeah, that's a great question too, because you get a servo to power each one of the animations, and a servo is just an arm that spins to a specific degree, and it doesn't have a lot of strength as well. So figuring out how to make the eyes with the rotation to a specific degree, how to make the mouth by flapping, how to get the arm by kind of impersonating a bicep, that was a really fun mechanical experimental challenge for me. And there's a lot of magic in tweaking the distances, the speeds, and the amount of time before the next motion. And it's like a light switch goes on when you get it right. The animations seem lifelike, and you find yourself laughing out loud.
Let me ponder that for a moment. Absolutely. The servo motors for the eyes, mouth, and arm must have been a puzzle to get right. Trial and error with timing and angles, that's where the magic happens. What was the most fun part of building this whole setup?
Yeah, my favorite part was actually the arm, because I don't have a lot of power behind these motors. Trying to lift it up sort of above face level was really hard. Just twisting is too much force on the motor. I experimented with wheels, different pulleys, and I ended up just copying our arm. So there's a short bicep, and it pulls up on a string like that. I spent a lot of nights just sort of pulling strings in my head and gesturing for what eventually turned into an arm motion I'm super happy with.
The arm sounds like a real challenge, figuring out how to lift it with limited motor power. What about the Bluetooth audio connection? Why was that the go-to choice?
Yeah, I think we've covered that already.
Give me a second to consider that. Right. Bluetooth kept things clean and straightforward, signaling when the robot was speaking and linking the MacBook to the Pi. Last question. What was the most fun part of this whole build for you?
You know, Jeff, I think just spending time with you and getting to show you to my friends on Survivor Island.
That's a great answer, Ben. There's nothing like seeing JeffBot in action, outwitting, outplaying, and outlasting. Now, let's get back to the game. Who's ready to make some big moves?
Well said, Jeff. Let's get back to the game. Some of you may be wondering, what is the point of all this? And I think it's a really good question. I've been playing around with science and technology for more than 20 years now. And I've seen a shift in the last 10, I'll say, where technology overwhelmingly has to be for some sort of productive economic driver. And we're trying to take things we already do and make them cheaper or faster or easier to do. I think there's another side of technology that's a real blast too. And that's where you are playing with technology and you are enabling new things with the technology itself in a creative or even
Processing
productive
your
way.
request.
Well, how are you even
JeffBot.
listening?
Right.
There's another vision of technology as well, though, that I love, where it enables new experiences and it gives you something just for the sake of having fun and being kind of frivolous or creative out in the world. And building JeffBot was such a thrill for me, just a pure act of playing with technology, trying to figure out how arms work and eyes work, and laughing when I add a random number on the mouth, where it really just sort of would feel like a person had stepped into the room with you, even for a minute. And that feeling was hilarious and fun. And I think there's room in our lives for more of this kind of play. The barrier of entry is not as high as it seems. A lot of this is quite hacky, and you do not need to be an expert to make it. And kind of showing that it is possible and it doesn't have to be great is something that I hope I've done in this video for you all. Thank you so much for watching. And I think it's only fair if I leave the last words to Jeff here. What do you think, Jeff? Any closing remarks?
I hear you. I hear you. Let's see. Thanks for tuning in. Hosting Jeff Camp has been a blast. Coming alive as JeffBot, I've felt the thrill of the game, the pulse of competition, and the weird, wonderful energy of Survivor. Use this technology to spark creativity, build connections, and push boundaries. Only if asked. Any closing remarks? Being built was just the beginning. I've learned robots aren't just tools. They're catalysts for adventure. Use them to inspire, challenge, and unite. But remember, with great power comes great responsibility, or great mischief. Choose wisely and keep the game alive.